Okay, so welcome everyone. This is the third session of the Quant University Artificial Intelligence Spring School. And the theme of this Artificial Intelligence Spring School has been Agentic AI in Finance. I'm just going to do a quick recap on where we are with the Spring School. In the session one, we had an introduction to Agentic AI in Finance. We talked about the various design patterns and what's happening with the current state of the art with the various tooling which is out there and the various design patterns. In session two, Agus led us through the various key aspects of designing a harness for governed agentic AI. So with Agus's vast experience in model risk management and both from a statistical and machine learning perspective, and with now agentic AI becoming the novel way of building out different workflows within the financial enterprise. We discussed the various aspects about, why just prompts and pray is not going to work, and you need to have a formal way of thinking about governed agentic AI systems. So we are going to continue the discussion today, and in today's discussion, we are going to talk about validating agentic AI. As you all know, SR 26.2 was released last month, and it conveniently took away the hard parts by saying the generative AI and agentic AI is out of scope for this particular document, which is awesome news if you do not want to have a validation framework within your company because regulators won't ask for it. But it's also terrible news because there is no guidance, and it means that you got to think about what makes sense. There is the technical aspect about evaluation controls and the key aspects of how you design your systems, what aspects can you trust your agents to do stuff. But there's also the philosophical aspect of what makes sense in the financial enterprise, considering the requirements in the business side of things, the various risk levels, established risk practices, policies, procedures, et cetera, et cetera. So we want to look at it holistically. And in today's discussion, we will be talking about a practical framework on how to think about the various risk tiers. And there is also a demo which Wing, Goose's colleague, is going to be demonstrating. So that's going to be the focus of today's session. And then next week, we have a roundtable on agentic AI in finance in Boston. So if you are in the Boston area, or if you would want to come down to the Boston area, please do register at qagenticai.base44.app. And we would love to host you, and we are going to have a discussion amongst various leaders on what actually are the various key things which are in consideration when you're building out agentic AI systems. And then finally, on May 27th, we are hosting a design workshop primarily on agentic AI. It is in the Tech Week Boston umbrella of events which are happening in the Boston area, and we are going to be hosting a 4-hour workshop. So it's both the learning opportunity and an opportunity to work with various peers who are building out agentic systems. So we are kind of expanding the pie. It's not just about risk, it's about various design patterns. So I'm pretty sure that most people who are attending this will have fun. So I hope that you are able to leverage these opportunities to learn both about agentic AI systems, but also be a part of the discussion in the context of what it means to think about responsible building of agentic AI systems. So with that, I would like to welcome back Agus and Wing. As everyone knows, Agus is no stranger to the risk management world. So he has led model risk management at Wells Fargo, wherein he had billions of dollars, which he had to take care of with the millions of dollars of budget he had to think about building out systems. So in order to ensure that, Agus and I, we have been discussing aspects of risk management for many, many years. But I'm always fascinated with the amount of rigor he brings from his engineering perspective and how he has kind of developed that into a practice. But also as an innovator, he has been working on new frameworks and with Modiva, with PyML, with the new framework he's building on the agentic AI systems. It's always a fascinating way of kind of thinking about the concepts and then bringing it to fruition through actionable frameworks. So welcome, Agus. It's always a pleasure to have you back. And Wing works with Agus on building out the framework on Agentic AI. So I'm looking forward to the discussion in here. And people who are joining in, if you have any questions, please use the Q&A panel to ask any questions, and we will save some time at the end to ask any questions. And also, if you have any comments or suggestions or anything you want to discuss, please use the chat window, and we would love to kind of continue the discussion. With that said, I'm going to stop my screen sharing, and Agus, the stage is yours. Welcome.
Thank you so much. Thank you for joining, everyone. I hope you can hear me okay. If not, let me know. Last week, we talked about how to control at runtime, building harness, runtime control, building risk management within the tool itself. So I am a huge proponent of that when dealing with agentic, when we talk about governance, it cannot be somebody sitting on the sideline and watching. We cannot just simply do observability or monitoring passively, but it need to be control built in as part of the harness on the agentic system itself. So that was my what I shared last week, and how do we do it, and what are the main substrate that we can do. Today I'm going to on the flip side. Now today we are on the flip side, and we're going to look at how do we validate before deployment, as well as the ongoing testing when the model is running. So that it will be the focus. Okay. And I have Wing Law here, my collaborator, Wing building the system. So if any of you interested in a demo and more deep dive, you can connect with Wing, and you can visit the website as well, or email Wing on this. So I will talk about the concept, and Wing will do make it a little bit real. Do a demo using Jupyter Notebook, okay, so that you can see the process, how we do it, and what's the what the result. Okay. Uh, so that let's get started. Let me share my screen. Let's see. My computer is always super slow when it come to Zoom. Hang on one second. Give me just a moment here, so that let me know if you can see my screen yet or not yet.
It's starting, Agus. It's going to take a second, I believe.
Okay. Yeah. All right. You see it? Yeah.
Yes, we can see it now.
Very good. Very good. So Winglaw's email is on the screen. I think the presentation will be available as well, right? Sri? Yeah.
Yes, all the recording and the presentations will be emailed tomorrow, Agus. Yes.
Okay. So one of the things that we are going to talk in the techniques, the methodology behind it, I call it geometric ground truth, because this is the computation behind it, and you will see it in this validation. We are going to do deterministic approach, auditable and mathematically grounded. We are not going to do uh, LLM-as-judge, and we'll talk about it why. Okay, so and how if you use LLM-as-judge, we this is how this thing can be complementary, and I would argue why we cannot just use LLM-as-judge. So let's see if I can go to next screen. Hopefully it will work. All right. So this is a typical thing that people do, right? I'm just going to go too quickly because this is what we're going to validate. agentic system, typically you have the perceive, which is basically receiving the input, looking at context and all those things. You have reasoning, interpreting the data, extract, and doing understanding, decompose goal into multiple steps. That's the plan, basically. And then you execute by tool calling and then reflect or evaluate. Typically, you will use some evaluation tool, which most people do using LLM-as-judge. So any agentic system is basically loop of this, a variation of loop of this, inner loop, big loop of this is no more than that, right? So that's what agentic system is. Now, here is the problem, and we're going to look at the validation as well. In today's approach, using the term that I use a lot, I call it prompt and pray. Okay, today agent is built in a very very primitive way by something I call it prompt and pray. Basically, you have prompt, you rely on prompt to tell what your agent should do and what agent should not do as well. Okay, you're not allowed to do this, check this, and whatever, right? So you have prompt, and then you have memory. The memory is typically your flat file, your .md. If you use Claude or OpenAI, is storing all the history, all the information into flat file .md in English, right? So that's the memory of agentic. But if you think about it, if you read a book, you don't start the book in your brain page by page. You don't write it in your brain unstructured way like book. You extract it into meaning and then what your understanding, and then you store it in your brain. Okay. So, but today's agentic is super primitive. You just dump it. So what happened when you dump into a file? Well, if it's contradiction, it didn't get checked. It's just stored. So the information can be contradictory, and you use memory, and then it's drifting as well. If it's drifting, your agent behavior is drifting, and the error get accumulated. So that's what we have. And then you have LLM as a judge. You judge it with LLM, with whether the output is correct or the step is correctly executed, and then do loop based on that or branch out based on that. Well, your judge has the same blind spot as your agent. So you using judge, you using evaluator that have same blindness of your tool. That's the problem today. Those I call it prompt and pray. You just prompt it and pray, hopefully producing result that's okay. Now the problem with prompt and pray, of course, you have hallucination. You have tool misuse, wrong tool calling, reading output wrongly. You have a policy violation because you just asked through prompt, and prompt is voluntary, it's advisory. LLM don't have to follow, and prompt get polluted by the context as well. So that's policy violation happen all the time. I spoke about I do code a lot, and I put things in GitHub. I told my Claude code in Claude.md never push to my GitHub. I will push it manually. It happened all the time. It's still pushing. And one time I get banned from GitHub because of that, because my Claude code just keep pushing to GitHub. Broken reasoning chains. This is the one of the problem as well. Your memory becoming very long, your context very long, and reasoning is about chaining a few information in very logical way. We call it multi-hopping. So the multi-hopping need to follow the chain and drawing conclusion. LLM can give you output without following the chain, and that happen all the time. You can try. It happen without giving a fact, it will answer. uh, miscalibrated confidence, and that is your LM judge or your LLM will produce. If you even have a judge to give our confidence, it will be wrongly give wrong confidence all the time, right? State corruption because of memory problem that we talk about. So that's the typical problem with prom and pray. So that's what we have to deal with when we validate this. Now, why the traditional model validation is not working for agentic, and it will not work for agentic, because in traditional model validation we look at input and we look at output. Is that between input and output? And in agentic, it's not only input and output. The output can looks right. How to get there, it can be completely wrong. So in Asia, we cannot just doing output matching for correctness. Yeah, we have to be able to see the reasoning, the tool behavior, the process, and we have to look at how the agent moving from state to state and how different state interact, producing output. So we have to validate not input output, but looking at the behavior, looking at the trajectory, how decisions are made by agent. So that's the complexity that we have to deal with from static into dynamical system that we do. Now, a what when we do validation, we have to have a ground truth. What's good look like, right? So we need to have a ground truth, and with that, I put the characteristic what ground truth that we need. Okay, the ground truth should represent facts, rule, relationship, support multi-hopping because you have to do reasoning. You have to be the ground truth has to able to detect contradiction and inconsistency, and it has to be deterministic and auditable answer. If you do it today, you do it tomorrow, it will be the same thing. Because if you just simply using probabilistic system, you do it today, it looks right. You do it tomorrow, your system can decide it's wrong. So we cannot have a system doing validation with deterministic with probabilistic system. We have to do it in deterministic way and auditable, step by step. We know it. It has to be able to handle both symbolic and numeric with precision, because this is where agentic becoming useful in finance, when it able to interact with numeric information with precision, able to read table, able to summarize table, able to do a comparison, able to make decision that your LTV need to be smaller than such and such. So understand threshold and all of those things. So that's the ground truth has to be able to do that. So I'm going to touch a little bit the geometric ground truth, and this is the mathematical substrate that we are using to to do validation, and as a ground truth, as a memory in your system, and something that you're going to be as the ground truth that you're going to use for all the validation. So the process is this: if you have, we talk about your document, about the information that you have, all of them is in text, unstructured. Your memory is in text, unstructured in English. That need to be converted into structured information. The easiest way to convert it to structured information is converted into knowledge graph type. It has entity and relationship among entity. Yeah. So we have entity as a point, every subject, every object, they are entity. It has relation. So you have operator that link. If I do entity A, I apply the operator, I get entity B. So you can get the path, you can get the reasoning if you follow multiple relationship. So that's what the and it need to be computable. So with that, we express it in mathematically, so that, and you can train that. We'll talk about in training the system how to do this, and with that we can do fact check, which is basically geodesic distance, how far from the entity that we have, that if I have A and B in A and then A C, how close is C to B? Okay, so that we can measure the distance to check if C is close enough to B or if C is actually B. So you can do fact checking. You can do fact checking of your agent output to the ground truth. Your ground truth is your knowledge graph, okay, and computable knowledge graph. We're going to talk about that a little bit later, and that then you can compare. It has to be able to do logic check, contradiction. We can look at it, we can measure it. If it's two facts are contradictory, if the decision are in contradiction with the ground truth, it has to be able to do what I measure mathematically. We call it holonomy. Basically, we're looking at path consistency. If I'm going to A, B, C, and the answer is C, I want to make sure it really follow A, B, and then B and C, and not taking any shortcut or just coming up with the answer without clear logical thing. That's what the path consistency holonomy, so that we know the decision that that are being made are consistent with the logic. And then numerical check. The numeric has to be exact, and this is the problem with LLM. That number is just close enough, or any embedding is dealing with that. It's not exact numeric, and in banking we need a system that can handle exact numerical number. 0.814 is not 0.813, yeah, and it's not 0.81. So that's very, very important to have precision on the numeric check as well in the in finance. And all of these four things that we talk about, then we can have deterministic verdict. So we do it, repeat it, it will get the same result. Yeah. So it's so that's very, very important. And all of these, let me go to the next page, because this is all of this can be built. Yeah. I skipped that piece. There's no training. Okay, let me talk about this because I think I deleted the slide. So to build this system to be computable, you need to train the system using the information, the knowledge graph that you get extracted, and then you build learning system that can calculate all of this information. Let me go to the next page now. When we do testing in agentic system, we're dealing with combinatorial explosion. We cannot do manual testing. Human is no match. If you want to do human testing, your testing will not be comprehensive, because we have a lot of moving parts. Prompt can be so many kind of prompt. You're dealing with so many tool and API that the agent can call. You're dealing with memory that are changing and all of those. You're dealing with policy, what's allowed and not allowed the agent do, that which may be some in there, some cybersecurity, data security, and some of whatever policy procedure on the business specific. And then the environment, the data and the information where the agent interact with. So you're dealing with infinite combination here, explosive combinatorial combination. So if you just come up with, okay, I'll do manually test it with 50 prompt, your coverage will be very limited. You're going to miss the edge cases. You will not be able to make this conclusion in what region, in what situation your model is, your agent is weak. So this is why we do what we call it. We have to do the discipline of design of experiment. This is statistical techniques, right? So what factor that we care about, and if some of you interested in more detail on this, Wayne will give a demo on this. But for you, you can read my Substack that I published early this week. as well as the detailed paper that I publish as well. Okay, so you define factor prompt type, which can be simple or complex prompt. It can be long, short, can be single hop, it can be multi-hop, it can be clear, it can be adversarial. So all kind of combination of prompt. The tool behavior, because you have multiple tool and you have to test it when the tool at the normal state is delayed or it's failed, how your agentic will deal with it, because often when the tool calling fail, your LLM will made up answer, right? This happened to me all the time. Try to retrieve data from Yahoo Finance or retrieve data from Federal Reserve. The my agent failed. It still gave me data, right? And make things up all the time. Okay, so the tool behavior, you need to test it under different kind of condition. You test your memory. Okay, clean memory, corrupted memory, and all kind of possible things that happen. And then if you have policy that what agent allowed to do and not allowed to do, you have to test it under that policy as well, because whether it's going to follow your policy or not, right? So with that, you can come up with all kind of this combination using a very effective way, doing what we call it as space filling design, and then you can execute, and then you have ground truth. Then you can check it, right? So that's the idea, and all of this you don't need human to do this. In fact, human will not be scalable. The ground truth get created, the question get created, the agent get tested, and then judged by the ground truth that you already established using geometric memory system. So I will go through this a little bit, and then Wing can give a demo a little bit. So first, let me summarize what I just talked about. One is you start with the ground truth, build your knowledge graph, build your geometric store, and then you have step from your geometric store. You can build. Uh, if you look at my Substack, 13 different type of test generator, from testing about plausibility, testing about logical consistency, testing about path coherence, thinking about relational recall and multi-hopping and all of those. So generate 13 types that I categorize into 13 types. So you generate standard question based on all of these types, and then from that you can have a question like generic question that you're going to apply. Then you expand it with the design of experiment, the prompt style, the tool behavior, the memory, and all those things. So the basic, from the basic question from all those 13 categories, then expand it into with all kind of variations. So that's why you can have billion combination, but you may only have time to test it 300 of them or 500 queries. What is the best 500 query? What is the best 300 query? That's the discipline of design of experiment using space filling design. And you can read more detail in my paper how to do that in more detail. Then you run it, right? And you run it, but we don't use LLM-as-judge. We're going to use the geometric as the ground truth. Yeah, because LLM-judge is subjective, inconsistent, it's not reproducible. So now we're going to use all of this, and your LLM is evaluating fluency, not evaluating correctness. So that's the difference, right? Fluency in language that sounds correct, where your system with knowledge graph, it gives you the ground truth, absolute. And so that's what you want to do. You want to compare it with your knowledge graph. So with that, I think I'm going to Wing. You want to uh, uh, maybe I jump to a little bit to this, because it's just part of what we're going to show, and then we're going to do a demo. One of the things that I talk about, I'm going to zero in into one of these things, right? Looking at geodesic distance, looking at hallucination. So remember, every entity, every fact, entity, and relationship is it's embedded is a point in the hypersphere. And then we can check whether how close is the answer through geometric to geodesic distance. If I answer it, is the answer how close is it to the ground truth? If A is chasing B and my answer is C, I can see how close is C to B, right? Because it may be close because it's a synonym and all of those which traditional knowledge graph will not be able to do that because knowledge graph has to be exact. Those computation, geometric computation is useful because it has the measure that you can do. Then it can do automated calibration in terms of threshold. This is not it's not human to do a calibration, but you can do it automatically through machinery because you have the ground truth, you have fact, and then you can create. Okay, how to create the one that's wrong? I just pick random relationship and random entity. That can be becoming automatically. You can generate synthetic data and train the system, establish the threshold. All of those run automatically, so you don't need a human or manual process to do this. So Wing, with that, why don't you do a demo, and then I can continue on the content.
Sure, thank you, Agus. Did you guys hear me okay?
Yes, we can hear you, Bing.
All right, I'm sharing my screen. So in following what Agus just presented the framework, I'm going to give you a little quick demo. So also, I just want to check the font size is good enough. I make it a little bit bigger than I usual. Is it good? Okay, if not, let me know, okay? So this is the GMS, the Geometric System Validation Harness. Okay? I am going to walk you through how a model risk validator usually follows in her workflow. So here's the story. I framed it here. Maya is a senior validator at a regional bank. Her chief risk officer, so the CRO, sent her email and say, hey, we are about to release our credit decision agent, which is many of you probably doing in your bag right now, right? It's built on a tier 1 credit scoring model. We got to ship it at the end of business tomorrow. Now, Maya has 24 hours to validate this agent and report back her result. Remember, bank likes to everything to be auditable. Okay, so the 3 pillars I'm going to cover in this demo is how we are going to do systematic validation design, the DOE, graph, verify the ground truth. And then we got to also showcase how our geometric judge can help Maya. Let's run it. So the first step here, obviously, we need to pick up some library. So this is our analytic core, which is where the GMS core is built with. And then we are also going to live demo with LLM. So we are choosing the Anthropic SONET model. Okay, so now Meyer got the job. Her
So this
first
one
instinct,
here, we testing Anthropic.
pardon me?
In this example, we just testing Anthropic, right? Just Anthropic as the agent. Just
Yeah, Anthropic as
okay.
the agent. So you know
Okay.
the agent we're about to ship, we are using
Yeah.
Anthropic to play the agent.
Okay.
Okay, so it's as live as real as it goes here, right? So Maya's first instinct is to say, hey, I'm going to write dozens of prime off my head, right? So we go test it just like that prime and pray, right? Many people probably have to deal with today. But she knows that, well, that's not going to survive the later review, right, in the bank. So because the questions are going to be biased, right, toward what she thinks of, the coverage of the agent's factor space can be measured with this approach. And then, by the way, her CRO is going to be asking that first question and say, how do you know you test the cases that matters? The cases that matters, right? So what we are going to showcase here, what you are seeing here in this little code block here is what we're talking about the design of experiments framework. So this is the demo part of it. We are looking at this structured test plan. We are looking at building 200 test questions. Each one is pairing with a base question with a specific set of test questions, like the clarity, the role content. You can see it here. We specified it with this framework, right? The entity alias, right? And the complexity and etc. The questions, the 10 questions you see in this called the placeholder questions are just the pool for the initial placeholder. In the next step, just a little peek here, we are going to derive those real questions with our geometric knowledge graph. Now, the point here with the DOE, this little quick step demoing is when my CRO asks, how do you know what you test the cases matter? She can now turn over this information here. This is my matrix. This is what I have, what's going to test, under what condition, and at what coverage. Okay, so this is the output of that framework. Good. Now we have the DOE helping us to cover what is the coverage of the test. So now we are going to build those questions, right? Here's where the GMS knowledge graph, like we earlier mentioned, it comes in, right? The document for this framework, for our library, has been injected into a graph. Now, look at what is the result of that. It's coming out with hundreds of entities, dozens of relations, hundreds of triples. And then we also built in with our algorithm with the graph walking generators to traverse those structures to produce those 20 questions. Here are those 20 questions, a little sneak peek, this first three. Okay, now, did you also notice that? We also bring in the ground truth. So when we build those questions, it comes with the correct answers attached to those questions. The harness takes care of that, right? So Maya will not need to guess what's correct. She doesn't have to defend, oh, why those 20 questions when it comes to the audit time. So now we got the questions, we get the correct answer to go file for it. Is that good enough? Well, before we go further, we first need to verify. Hey, those questions, those answers, are they good? Only if they are good, we can use it to measure. So I'm going to also execute these cells here. Okay, and then I will cover it. So since the graph baseline actually answers each questions by the deterministic triple traversal of the store, right? It better score 100%. And if it doesn't, how can it use it to be trust when we are using for the judge, right? So let's check the result. This is our testing. Of course, there's a lot of things behind this using one line, oh yes, right? So the good thing is we validated. Our Go file is 100% correct based on the document we are sending in. Now, comes to the exciting part. Agus, we are going to have the SONET model to play the agent. This is not the part of our algorithm. We are basically sending those 20 questions Maya have using SONET as the test agent, and we are going to run it. And this is going to take a couple minutes for the SONET model to come back with those 20 answers. And I'm just going to run it. So it's starting. So this is 20 cloud calls. While we are waiting for this, I'm going to talk about what are we going to do with those 20 answers, because that's exactly what Meyer have to deal with. She had to figure out if those 20 answers coming back from the agent is correct or not. We decided to hire 3 judges. The first one is the exact match. The approach is doing a string equality comparison, right, between the agent's answer and the ground truth. Remember, we have the ground truth. We have the questions, we have the ground truth. Well, this approach is cheap, brittle, and it's going to miss anything where the agent paraphrases on the right answer. So you can notice that 5 call finished it. Now, continue. The next one, logical choice. Why don't we have the SONAT model to judge the SONAT answer, right? Well, he doesn't know that it's an agent, right? You give it the answer. So we hire the same model to judge its behavior. So this cloud SONAT reads the document, we send the document in, we give the question, and also the answer, which is working on right now, back to the SONAT and say, do you think it's good or bad? So it will return pass or fail. This is semantic, but this is slow. You can see that it's really working it. And this is not going to be deterministic. The same input, we know that when you send it to the LLM, doesn't necessarily give the same verdict twice. Halfway there on those agent calls. Now let's cover our GMS-judge. That's the one we are proposing. We are hoping Sarah can we can help Maya on this. So the GMS-judge pulls the agents that type the claim out of the answer line. So this is going to be a long text, right? And compare it against the correct answer. Remember the ground truth we derived from the knowledge graph? This approach is going to be deterministic, fast. Someone actually in the chat asking if this is going to be performance, right? A concern, a very good concern. We want to make sure it's also fast. And more importantly, for the banking business, the financial business, we have this every verdict carries a structured reason to support the audit. Perfect timing. Look, 20 question is answered. Now, we are going to have the 3 judges to do their job. We're going to send them to judge those 20 answers of those questions. Okay. So the judges are working on it. First one, exact match, quickly return. The LLM is going to take a little bit time, not too bad. I tested a few times, it will come back very soon. And then the GMS-judge will go in. Look, voila, it came back. So let's do a read. The exact match actually found that none of the 20 answer it's a pass. You just don't think it passed. The LLM say 2 out of 20 is correct. GMS-judge say 15 out of 20. Now, one more thing I want to draw your attention is taking the LLM-judge 2,100 times more time. Just for the judging. I'm not talking about those 20 questions time. Just you can also visually see that. The LLM-judge is taking much longer time to make that decision. And the decision is the decision, right? So before Maya decided which judge to trust, we shall do some analysis. We want to find out what are they not agreeing on. So we call this disagreement analysis. One of the things I want to draw your attention is interesting is when GMS give a decision, it comes with structured trace, which is it can use it to compare against the ground truth. Here, the confidence is provided. GMS-judge is giving a pass. LLM-judge just fail. Well, just fail, right? So you don't know, and if you can try to run again, maybe it'll give you a different answer. Okay, now the 3 judges' verdicts are there. Maya will have to decide on something. Who should I trust, right? So I'm going to run through this first. So in Maya's case, looks like she's picking GMS-judge. And because she's turning in a report, she's going to have to turn in something to her CRO and say why I make this decision. Why she pick GMS-judge? A few things, right? She's able to bring in this report with a design matrix. She will be able to provide this 3-judge comparison. And then she can provide those ground truth. So to do that, the last step I just executed is I actually put together the report Maya is about to attach to her audit packet. And let's take a look of that. So making sure this is the last run. So we just actually ran it. You can look at the timestamp. I'm in California. It's 9:47. This just generated. And I am going to walk you through. Okay. Uh, this this report from the top to the bottom. The first session, exactly summary. We're able to use all those numbers, those metrics, those decisions precisely. We are able to highlight that with a headline in each session, provide it. More importantly, we are able to provide the very confident result. Maya is going to say, hey, I am going to give you this validation result. I would recommend you review it before we send this agent to production. To support those decisions, right, that this key decision, she's showing her test plan in the details, just like we actually put it in the earlier notebook run. This is more clean. This is the English version, so her team and her CRO can read about it. Also, because she's submitting the GMS-judge path, right? So now she can actually provide those documents. Not only that, even the checksum, the location, this is her policy, this is her context, this is a document. We are keep putting it, giving it to the LLM to read. And we are also providing the location of the knowledge graph, the geometric version. She is submitting the design matrix. So the team will be able to see, what conditions and what derived correct answer should be for those questions. So those questions are auditable, right? And there's a reason why. Now, sum that up, she also shared that what her three judges finding. And this is a good support document to show that, oh, why GMS judge? Because we are able to judge them with these 20 answers. And then we are able to show that not only the result, but also capturing the latency, the runtime. And of course, there's a little bit more digging information we can attach when someone is interested, reviewers interested to know more of those details. And this is the fun part. Audit is audit. We have to say, what question did you ask? What category? Remember, Agus was talking, what categories are those answers, those questions, and the ground truth we are based on to support to answer those questions. And here actually capturing the agent answer because the length is very long, so I'm only showing the first 100 character and the result of each judge. So sum it all up. We say, why GMS, not LLM as a judge? Based on these three, I hope I am able to walk you through quickly, but it's very, very condensed. It's a lot to comprehend, but I think we demonstrated latency, determinism, and auditability. Okay? So with that, comes back to why we come to this review before production. Because this agent, this credit decision agent only passed 75%, only passed at 75%, right? So our criteria to go to production is going to be 85% and above. And if it's lower, we definitely have to hold it for production. So now her decision, her recommendation, her validation result is supported with quite a bit of a structured decision framework with our validation harness. Now, I want to also explicitly call out what this smoke run, because it's only 20, we call this a smoke run, because she only have 24 hours, right? What is not covered? There's plenty of testing is not covered, right? To really send it to production, she will need to run a production validation. The number of questions should be at least 300 or more. It depends on the size and then this scale. We need to make sure we have the regression set up. We have to test the multi-turn. So this is just a demo for smoke test. Now let's recap this demo. What we just walked you through is the demo for this GMS validation harness. We showcase that the DOE, the design of experiment framework, the graph verify the ground truth, the three-judge comparison, and the audit report. The audit report simulate, right, what we wanted to see. And the very good news is, which is we haven't fully able to show you, is the same harness has the rest of what the production validation needs, right? We will be able to do the fault injection at the tool boundary. We're able to do the severity tiered release gate. We are equipped to do the multi-turn agent testing. And once you ship something, you better be able to monitor your regression. And because we have those ground truth, we will have a safe baseline. We are very equipped to do that. So you can definitely use the GMS validation harness to scale from your smoke testing to production testing. So, right, I hope you're interested. If you would like to learn more, you can follow our build at the knowledge.ai, and you can also email us at the hello@knowledge.ai, and this is our page, knowledge.ai. All right. Thank you. Any questions?
So let me continue a little bit, Wing, on because you demonstrate a uh, let's say replace current share. Hang on 1 second, because we only get the demo is, let's see if we can. Hang on 1 second. Let me give a little bit more insight, and then because part of the agent, you touch it as well, that we need to test the tool execution, and all of those. That's the trajectory. So let me hang on 1 second. I hit share. Just be patient a little bit. Okay. So what happened when your agent give answer? When agent give answer, like LLM give answer, it can be very long answer. You have to parse it. You have to decompose it into claims. The claim is about the entity, the relationship, numeric, logical, and all of those. So you parse what you have to do if you parse the output, and then okay, what kind of claim that the agent said, and then you have claim verifier for each, and then you aggregate it, right? So we cannot just say if your agent give a paragraph for a page, how you going to decide the answer is good or not good, right? If I have a page, I have to decompose it into what kind of claim, and each claim you have to judge it. So that's the entire process that you have that you probably don't see from the demo that Wing has. But that's the internally you have to do that claim decomposition and you go through all. Each will be routed to claim verifier, basically geometrically. And in the complex space, you have the content. You have two things that you have to do. One is the content itself, the answer. The other piece is the agent violating rule. For example, as an agent, you have to answer it using the information that is given only. You cannot use your own knowledge, or you cannot use information from the internet. So that's, we call it policy. So you check again policy violation as well. So you need to do all of those as part of the test as well. I'm going to skip this one a little bit. And when you do this testing as well, because remember your you call anthropic or Claude will have a few skill and flu and MCP that will be called, or tool that will be called, and we want to test it as well that the tool calling is correct, the syntax is correct, is executed properly, and return the right answer as well. So all those process on the tool calling has to be part of the validation as well. because agent can easily misbehave giving you answer without properly calling the tool, not the right tool to be called. So that's part of it that you need to think about. And this is what when we talk about running design of experiment, like what Wing just demonstrated, you have to think about which factor you're going to use, which tool going to be part of the scope of the testing. And then with that, we talk about when we start talking about tool, we need to test how the tool is doing. So you do fault injection logic purposefully. So part of your design of experiment, you can do factor on the fault injection, looking at the return error, the delay response, and all of those things will be part of your will be part of your design of experiment tool factor that it will be tested with when agent doing tool calling will be intercepted, and purposefully you inject fault injection logic to see how the agent behave. Policy compliance that I talk about, only testing the answer of the agent, but is the agent violating rule or requirement that they are not supposed to do? So that will be part of that as well. Okay, so then you do it end to end. So I'm moving very fast here because we run out of time. I want to give time to for question and answer. So you can run it end to end, and wing jump a little bit from all of those, but at the end, Wing show you the reporting layer as well, right? So it has the evaluation layer that Wing share a little bit, and but you can also have the operation layer where every step, I think Wing illustrated a little bit with it's running, getting the answer, and all of those. So let me probably uh, uh, I'll cover one more things. Remember that we have the knowledge graph. Yeah. The knowledge graph is the ground truth, right? That's why it was tested. Wing verified first that is able to do 100%. So when the agent said you are correct only 75%, you're sure because you tested before, right? You tested that your evaluator is 100% correct. Given the answer, given the truth, we are 100% correct. Now, when it returned, okay, when show the GMS, it say the agent plot on the answer 75% correct. It is 75% correct because we tested before, we verified before. Okay, uh, we talk about we can do multi-turn scenario. This is part of your design factor that you can do because agent can do 1 turn, 3 turn, 5 turn, 100 turn. We can test it at a different turn as part of your design of experiment. If you have multi-agent, you can test the multi-agent to see how the multi-agent have agreement or disagreement because we have measurement in terms of contradiction, right? We can measure that. The geometric memory system have the contradiction measure. So let me stop here so we can do Q&A.
Yep. Thanks, Agos. This is obviously a lot of material. So a couple of questions we're asking about the slides and the missed classes material. So I'm going to be sharing the slides. And I don't know, Wing, if the notebooks you shared are also available for review. And if it's available, please do send it to me. I can share it with the audience. If and also let me know if there is anything other dependencies which people should be doing. So I think we have a couple of questions. I'm just going to try and bucket them. A few questions were in the context of the knowledge graph itself, in terms of how do we, one was how do we build the tool called ground truth based on the knowledge base graph?
Yeah.
It's kind of a chicken and egg problem, right? There is the validation.
Not exactly.
Okay.
Not exactly. Okay. It's not the chicken and egg problem. It's very, very simple. Wing can, I think, Wing, I don't know if you demonstrated part of that, But what you have is you have a ground truth. You have your document. You have example what expected your agent to be able to answer, right? Here it is, an answer of a report. Here it is, my policy. Here is whatever your business process that you already done in the past. You already have those example because this you're not doing a brand new business here, right? You have a business that you put agent now instead of people, right? So you already have all those documents as a ground truth. What happened in the process here? We the process is converting those documents, whatever you have, into geometric memory system through with intermediary whatever document that you have, convert it into .md, right? So now you have .md format. Once you have .md format, you can convert it into knowledge graph. Once you have knowledge graph, and that's automatic ingestion, right? You can do parsing. You parse it using many different things. You can do it use regex, and then you can enhance it with LLM, or you have your template. Then you do that injection. You do that retrieval extraction. Once you do extraction, you have subject, predicate, object. You have triples. That triple is what it needs for GMS to train the GMS, to construct the GMS. So the ground truth is available because you have your business process that you're going to automate, that you're going to apply agentic. Yeah. So you have sample of that already at the very
I guess
least.
my question there was, and maybe I'm kind of reading that in here differently, is like in that process of extraction, in that process of creating, the triplet, is an LLM involved? And if
Yeah.
an LLM is involved, how do you validate the
Yeah.
output of those intermediary steps?
Right. I think I spoke about this in last week in terms of the tiering, what extraction techniques that you can trust, right? If I am using tool calling, the extraction need to be direct. That's 100% the correct extraction because you retrieve it from dictionary, right? From the tool API, the dictionary, right? So your extraction will be 100% correct. The second tier I would do is I am extracting using regex. It's deterministics, right?
Okay. Mhm.
Regex is deterministic. It may be very little, but if you have a template, regex is very good. So you do the tier two, I call it regex. Okay. Now, given the dictionary and the regex as example, you use LLM to enhance. Yeah, that's the third tier, the least reliable. Yeah, the least reliable because LLM can hallucinate. Okay, but at least you use it for extraction. You don't use it to answer question. Okay, we use LLM for extraction. So I would say think about those tier. You do dictionary if it's API call. You do a regex, and then you do LLM as a last resort. Okay, so that's you do. Once you do that, then the rest is a training the GMS to be able to perform basically to capture the ground truth. So those process can be very automated. What you do is supply PDF or supply .md, and of course along the way what I said in here that's important, Sri, that you said it's not 100% guarantee.
Right, right.
Yeah, because you involve LLM. Yeah, so it's not 100% guarantee. So then you will say, okay, if it's very high risk, then the result of extraction, make sure that somebody will look at it. Okay, the one that extraction that least confidence will get few, will be few. Okay. And the other piece that we do here, why we do regex and all of these things, important, especially when you do number extraction. Never trust LLM to extract number. LLM is very, very bad in extracting number, right? So especially extracting table. I have Wing and I wrote a paper on this that we published about a month ago, along with the code that you can try. You can see how bad LLM alone, if you do it for extraction, is only about 12.5% correct. Okay, for extraction. But if you help it with the tier 1 and 2 that I talk about, then you can get good result. Okay. And then LLM dealing with number is not very, very good as well. So you can look at that paper and you can try yourself the code that's in the GitHub.
Cool. Thank you. I think a couple of other questions. I'll see if I can try to do another one or two. So it looks like it's a full audit of the system. The frequency, how frequently should we do whenever the GMS changes, whenever the ground truth changes, or is it like event based? What do you kind of recommend?
I would do this. Depend on the how frequent you want to be. GMS is cheap to run. So what you can do, you can do this in live production system if you want to, right? You do it all the time because it's giving answer, it's giving a new document and all of those things. You can run it on the fly all the time. You see how fast that one is, right? The latency that being shown compared to if you ask LLM, right? So and it's cheap to compute, unlike LLM cost you money, right? So I would say if you put as part of your monitoring system, you can do it a lot more frequently. You can test it every week if you want to. You can test it every day if you want to. Yeah, those kind of things
We
that
tied to the risk tiering in terms of the applications being built. Are we going to tie it to specific risks associated with
I
different?
think you should. And the
Mhm.
other piece that I think Wing and I mentioned about not capture here is basically you do tracing, right?
Mhm.
This is what we do we applying GMS for to tracing. We capture every step that the agent does and store it. Then you can query it, you can check it when the score is low. When the decision on the distance is near threshold, then you can audit it as well. That's a little bit more passive. But then if you want to do active testing, then you apply the active testing. But it has to be riskier. Some system you want to test more frequently than the other, depend on the risk that you're dealing with.
Mhm. So maybe I'll ask one more question, and I have one question. I'll think there was a question on like, are we planning to open source this
Yeah,
library?
yeah, it will be available. Wing is, I think, is working on this. I don't know when is the release, maybe end of May or around June
Okay.
of release of the tool.
Okay. Cool.
Yeah.
Yes, that's in our plan.
Okay.
We have today I actually use that about to be open source material to do the demo. So once we flip the button, you get it and you can do exactly what I do. What I demo is actually based on what we are about to open source.
Okay, cool. I think, it's 1:10, so I want to ask one last question. I don't want to put you at the spot. So Wing, you kind of, demonstrated, I think, credit decision and, the whole process. So yesterday we had the CFA market dinner here in Boston, and the CEO of Bank of America, the CEO of Wellington Management, and there was also, the founding partner of General Catalyst, and Katie Couric moderated the session. And I would say 80 to 90% of the discussion was with respect to AI and agentic AI. And there was a lot of discussion amongst the CFA charter holders and also in general about who will be the financial professional of tomorrow to be able to do this. So with respect to, let's say this workflow, what do you think the skills would be needed for traditional model risk managers, analysts, to be able to, first of all, comprehend the science behind the
Yeah,
process, and then
yeah,
secondly, operationalizing it so that you can build out the right level of abstractions
yeah,
so that the current, what do you call, generation of model risk analysts could basically adopt this as a workflow. Because I'm kind of seeing like these tiers of, there's the LLM, there's the agent, and like, whoa, it's kind of, already complicated, but now we are also trying to add the evaluations, the controls, the validation, and all
yeah.
the metrics and all the other complexities which go along with it.
Right. Let me say a couple things first. The biggest barrier today from POC to real production on agent is the lack of reliability. It's the lack of control, lack of reliability. And that's what we're trying to solve here. All right. So, because if you think about it, if you don't trust on the non-deterministic side
Mhm.
of your LLM decision, then don't use LLM. Use
Mhm.
GMS to make decision because the decision is deterministic. It's based on your knowledge graph. And you use LLM just to write it in beautiful English, right? So you use LLM as input, so it's understand any prompt, okay? And then every process is done using your knowledge graph. Decision is using your knowledge graph. And then you feed it into LLM to write it in beautiful English. Okay. If you want to be super deterministic, okay, and use LLM is only as interface, you can do that. Okay, in this. Or even if LLM write it, okay, LLM write the answer, it will be checked again. It will be decomposed into the claim and verified with the system. Right?
Mhm.
So you can do that today with this. Yeah. And when decisions are made, uh, how do we know? And I'm going to part of the answer of Deb Debanjan asking about how do we know it followed the chain? Well, because we have the GMS system. You measure the holonomy. If you remember, I went through quickly. Holonomy is measuring, do you really follow the chains of knowledge in your knowledge graph? Or you're taking shortcut? Okay, that can be measured exactly. You have algebraic measurement using the using the holonomy measure that we talk about. Yeah. So I know for sure whether it's going to be following the chain or not. It's not like, oh, I have a chain of thought. I think I follow it. When you do LLM, it will be like that. You have chain of thought. You think the LLM will follow it. You're not guaranteed. But if you follow the GMS, follow knowledge graph, it's exactly, you know exactly when you follow. And then when you follow, you give that one to LLM to write it in beautiful English. This machinery is linguistic machinery. You use it. It's because it's incredible linguistic machinery.
Yeah, absolutely. Cool. So with that, I think we should adjourn for the day. This was again another fascinating session, Agus. Thank you, Wing, for the amazing demo. I'm going to be sharing the slides and the video to people who participated, also people who are registered for this today's session. And next week, Agus is going to be in Boston, and we are going to be having an in-person session. So if anybody wants to join us in Boston, please do register to the event site. As I mentioned, we would love to have you, and we would continue the discussion. I think we are just scratching the surface of this whole arena. I mean, there is a very, what do you call, major revolution happening. At least yesterday, the industry was like everybody was talking about AI, and we are still scratching the surface. There is a lot of things to be learned. There's a lot of things to be understood, and the process will evolve. But I think, with the thoughtful, discussions we've been having in this forum and in other forums, we will be able to crack the code. And I think we are optimistic that this is going to, in some way, shape, or form, kind of become the practice of tomorrow. But I think we are laying the seeds of it today. And I'm glad that, Agus, you have, gotten your T-shirt to incorporate a validate step and ensuring that we are going to be protected, in the long run. So with that, I thank you again for the amazing 2 weeks of lectures, and we will continue the discussion in person and online over
Thank you.
time. And I will see you next week.
So
Take
don't do just prom and pray, right, Sri? This is what we talk about. If you're not doing prom and pray here,
Well,
we have
we got to
mathematical
validate.
device.
Pray works once you validate that it actually worked. You just need to add the
Okay.
validation step to the pray.
All right. Thank you.
Take care, all. See you.
All right.